Hello there. Today we'll be doing number 44, generate parentheses. This is a stack problem as well as a backtracking problem you'll see very soon. In this particular problem, we're given n pairs of parentheses and we're generating all combinations. Whenever you see all combinations, you can think, oh, backtracking, when we're thinking all combinations. So we're trying to generate every single combination possible with 3 open parentheses and closed parentheses. This means that we have to find a way of adding 3 parentheses and getting every combination, as well as getting closed parentheses for every combination. So how do we do that, right? So one condition is that when all open parentheses must equal to the closed parentheses, and that must equal to n. Then we have a possible output, and we can make sure that we have less than like a open parentheses and a closed parentheses. So let's say we open a parentheses and we make sure that this count is always going to be lower than n, right? Because we want to make sure that we can add 1, we can add 2, we can add a 3 when we have 3, but not 4, because we can't close a 4th one. I mean, it's just out of range. Also, we must make sure that the closed parentheses is lower than the open parentheses, because if we have anything that's over the open parentheses, we can't close it. We can't close that, which is not possible. So if we have one open one, we can only make one open one. If we have another open one, we can make another open one. If we have another open one, then we can make another open one. So that's how we do this. So how do we get all the possibilities for this, right? So suppose we look at this and open parentheses is less than n. So first of all, what's going to happen is that we're going to keep opening parentheses until we have 3. Then we start, well, basically, once it reaches n, we can start closing them. So we can close 1, and it has not reached that point. We can close it again, and we close it again. We close it 3 times. And we have closed the entire loop, and we get this particular outcome. And our first item is going to be open, 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 this item. Then we start popping items. So what happens is that we start popping our open, closed parentheses because we have hit our particular spot. And so we pop, 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 and we pop again, and we pop out of all of these cycles, and we get to this particular point where we have 2 items that are open, because we have just popped out of, and then we start making closed parentheses, and we start making this one, and what happens after that is that we try to open it, and we close it again, and close it. So then we have, let's say, another possibility, and so on and so forth, until we get a total of all our possibilities. So that's backtracking. I think there's a lot more to learn about backtracking when we do backtracking problems, but this is how we are using this particular stack to make sure that we have closed parentheses and open parentheses in the correct placement. Can we use a string for this? Let's see. I think so. I think we can. Like, we just have to make a brand new string every time. We just have to append it to the string, and remove an item from the string every time. Yeah. So visually speaking, this is how backtracking works. It's about like generating all the possibilities and creating those possibilities. How do we get to this particular? The thinking is, how do we come up with this solution? That's the most important thing. So the way we can come up with this solution is that what we do is we see the backtracking because we see all combinations. Then how do we develop the backtracking is that we look at the what's our optimal case, and we make that our optimal case and add that to our output, our combinations. Then how do we get those combinations is that if this is lower than n, let's keep adding this to the stack, and if our closed items is less than open of n, let's keep adding those to the loop. And with that, we can open and close every particular path, and we take every single path possible and generate our answer. Okay, so let's make a stack and let's make our output. So I'm just learning this straight from Neetcode, so I think there's a good video on explanations about like how he came up with the solution and how I think about the solution. It's a little different. It's the same solution though. So make sure that all the items are equal. Once they're all equal, that means the open parentheses and the closed parentheses are equal, so we can append them to the stack. So we join the stack in the string and we append it and we return. This is our n case. So if open n is less than n, so we can keep appending open parentheses into our stack, and our backtracking will open n plus 1, and our closed n will be nothing, will not increase. So now we know that, oh look, we send this backtracking in. We have an open parentheses. Let's keep backtracking. Let's see if we can get to that n case. And so we will look at all the cases where we append all of the open n first. Then we do the first pop. And after that pop, we're going to go into this cycle here where we start closing the n and the open n. And what happens here is that we have two opens and two, so we can start adding one close. And then we add another open because, oh look, we do the backtracking, we go into a loop. Oh look, we can open again, let's open. And then we close it again. So stack.append. And once we hit a return cycle, we return and we pop all our items. Until we hit a point where like we keep popping until we are done popping, and we are in another cycle where we have backtracked to the point where we can do something different, which is another pop from open n, and we recycle that logic. And with that, let's run backtracking of 1 and 1 so that we can start growing this thing and return the output. Let's run the code, make sure this works, and then let's do some more analysis. So submit. All right, great. So what we're gonna do is for every backtrack, let's print the stack. run the code. Okay, let's take a look at this code here. If we can get this to, if we can bring this up, forget it. Okay, so I don't know if it's, it doesn't look to be possible to make this any more open. So we opened, as I said, and we closed. Then we popped off the 3 closed items and we closed again. We'll popped off even one more open one. We closed, created another one of these, as I said, where it's open, open, close, open, close, close. Then we pop those off and we try 2 closed ones because we're done with this open. We start closing again. And now we have 2 closes. It must open. Then we pop off all of these items until the point when we have an open, open, and we can start closing first, because that's when the point where we popped off everything and we get to this particular point and we start closing again, and we open and close, closed. And as you can see, what the next one's going to be is that we're going to open, close, open, close, open, close, and then that's how we get our 5 combinations. Hopefully that made a lot of sense about what's going on here with our code by printing out the stack, what's exactly happening with the backtracking. Hopefully that makes a lot of sense on how we're getting all of the possibilities. I know that this is an unfamiliar pattern, I think, to a lot of us, because we haven't done the backtracking problems in the Neetcode150. And I think we're going to get more familiar with backtracking and looking at this particular pattern and how we can use it and apply it. And this is one way. I'm sure that when we see these patterns more and more, we'll learn more and more about backtracking, and we'll be able to better do this more quickly and find these patterns. Well, I hope you learned something today. And if you enjoyed the video, like and subscribe. And if you want more videos, check the link in the description below. Thank you very much, and I'll see you in the next one.